This is May 2022, Foundation, paper number 1, so non-calculator for Edexcel. Let's have a look at this paper and see how we would have gotten on. So change 40 centimetres into millimetres. The first thing you do when you change between centimetres and millimetres, I would like to write down what I know is true. So I know that 1 centimetre is equal to 10 millimetres. And therefore I know if I'm going from centimetres to millimetres, I'm multiplying by 10. And if I'm going from millimetres back to centimetres, then I'm dividing by 10. In this question, we're going from centimetres to millimetres. So we're going to be timesing by 10. So 40 centimetres, 40 times 10 is 400 millimetres. So 400 would be our answer there. Question number 2, and we've got to simplify E add E add E add E, and that is going to be 4E. So really common that people confuse E add E add E add E and E times E times E times E. This one would be E to the power of 4. Okay, so that's just something that they also quite commonly like to ask, but in this case, E add E add E add E, that is 4E. Question number 3. On the grid, reflect the shaded triangle in the mirror line. So at the minute, we are 3 squares away on this side, and we need to make sure that when we reflect, we're also going to be 3 squares away on this side. I'm going to use my ruler for this. Let's just change that to black. So it's going to come out to this point here and back in and look like that. So we've reflected it in the mirror line. It's touching the mirror line on this side, so we'd expect it to be also touching on the left-hand side. So that's correct for that question. Question number 4, write down the value of the 6 in the number 16,007. So the value of the 6 is actually 6,000. Don't write thousands. Yes, it's in the thousands column, but they want to know how much is that 6 worth. So it's worth 6,000. You can write 6,000, but don't just write thousands because that doesn't actually say how much it's worth. Question number 5, write these numbers in order of size, start with the smallest number. So you might find it helpful to get them all in the same format. We could say that a half is 50%. We can say that 0.55, that's 55%. And we can say 45%, well, that's 45%. So therefore, from smallest to biggest, we're going to start with 45%. And then it will be a half. And then it will be 0.55. So converting them all into the same format is helpful, but you didn't need to show any working there. You just had to get it correct because that was only out of 1 mark. Question number 6. The pictogram gives information about the number of hours of sunshine on a Saturday and on a Sunday. Work out the number of hours of sunshine on Saturday. So we can see from the key that each of the sunshines is worth 2 hours. Each of the sunshines, each of the suns, I don't know, is worth 2 hours. So we've got 2 there, 2 there, 2 there, 2 there, 2 there, and 2 there. So on Saturday, it would be 8 hours in total, and on Sunday, it would be 4 hours in total, but they've just asked us about Saturday, so that would just be 8 hours. Question number 7, Simon buys some candles. Each candle costs £2. Simon pays with a £20 note. He gets £6 change. Work out the number of candles Simon buys. So if we start with our £20 and we take away £6, we get 14. So he must have spent £14 in the shop. So if he spent £14, the question is how many £2 would fit into that? How many 2s go into that? And to do that, we're going to divide. So 14 divided by 2 is 7. So he must have bought 7 candles to have spent £14 and got £6 change. 3 marks for that one. Question number 8. The bar chart shows information about the total rainfall each month for 4 months in a city. In May, the total rainfall was 35, and in June, the total rainfall was 20. Use this information to complete the bar chart. So we just need to draw our bars in for those two. So for May, it's 35, so we're going to go up to 35 on the graph. And for June, it's 20, so again, I'm going to go up to 20, and it should look like that. Rupert says, in February there was 15.5 centimetres of rainfall because the bar is half a square over 15. Explain why Rupert is incorrect. So Rupert is talking about this bar here and saying that that is 15.5. But each square is not going up by 1, it's going up by 5. So half a square is not half, it's actually half of 5, which is 2.5. So there's a lot of different ways you could say this. You could say, no, it's 17.5. No, it's 2.5 more than 15. So I'm going to put half a square equals 2.5, not 0.5. So that would be 17.5 for that rainfall. Okay, question number 9. Here is a sequence of patterns made from grey square tiles. Pattern number 1, pattern number 2, pattern number 3, pattern number 4. On the grid below, draw pattern number 5. So we can see that every time we go up a pattern number, we've got one more square added on to the right-hand side and one more square added on to the bottom. So we can see that this is going to go across 1, 2, 3, 4, 5. And go down 1, 2, 3, 4, 5. There we go, something like that. Complete the table. Pattern number 1, pattern number 2, pattern number 3, pattern number 4, pattern number 5, pattern number 6, and how many squares. So we can see that because we add one to the side and one to the bottom each time, this is going to be adding 2 squares each time, because we're adding one to the side and one to the bottom. So this had 1, this had 3, this had 5, this had 7, and the one we drew had 9. So the next one after that, we don't need to draw it. We know that it would add another one to the side and another one to the bottom. So that would be 11. Question number 10. In Norway last year, the lowest temperature was minus 15 degrees C. In Norway last year, the highest temperature was 42 degrees greater than the lowest temperature. Work out the highest temperature. So if we're thinking about a number line, let's imagine 0 is here, and the lowest temperature is down here at minus 15 degrees C. Now it's saying to get to the highest temperature, we need to add 42 from that. Now we know it would take us 15 to get up to 0. So to get to here would take us 15. So I need to know how much more to go on this side. And to do that, it's going to be the difference. What is 42 take away 15? Now, if there's more on the floor, we're going to need to borrow from next door. So 2 take 5, we can't do that. We're going to borrow 1 from here and make it 3. 12 take 5 is 7, and 3 take 1 is 2. So that is 27 degrees C. Question number 11. At the end of October, Fiona's electricity meter reads 88,738. At the end of November, her electricity meter reads 89,198. Each kilowatt hour of electricity Fiona uses costs 16p. Work out how much Fiona had to pay for the electricity she used in November. So this is how it works. If you look under your stairs or somewhere in your house, there'll probably be a meter like this. And every time you use a kilowatt hour of electricity, it's going to go up by 1. It never goes back to 0. It'll probably be 0 when your house was built or whatever. But when you move into a house, you call up the electricity company and you say, look, this is the number it's on at the minute. And then it will trickle up, and then at the end of the month, the difference will be how much electricity you've used. So to work out how much electricity Fiona has used here, we need to get the difference between these two, which is going to be to subtract. So 89,198 take away 88,738. And the difference will be how many kilowatt hours of electricity she has used. So I'm going to do the top take away the bottom. 8 take away 8 is 0. 9 take away 3 is 6. 1 take away 7. Now again, more on the floor. We're going to borrow from next door. 11 take 7. That's 4. 8 take 8 is 0 and 8 take 8 is 0. So she's used 460 kilowatt hours. Now we're told that, I should have done a capital W. We're told that every kilowatt hour of electricity that she uses is going to cost 16p. So now we need to take the 460 and multiply it by 16. Now you can do that in 2 ways, and I'm going to show you both methods because people are quite split on this, and both methods are recognised. So I'm a GCSE examiner, and both of these would be on the mark scheme for GCSE. So we can do it this traditional way, or we can use something that I tend to call the lattice method, which is where you draw boxes. Now you're going to draw 3 boxes going across because you've got 3 digits in that first number, and then 2 boxes going down because you've got 2 digits in that second number. And then we just write them over the top and down the right hand side, and every box gets split diagonally. Now that might seem really complicated, but that's probably the most difficult bit of that method. and then just make it a little bit longer for somewhere to put your answer. Okay, so let's go to the traditional method first, traditional column method. 6 times 0 is 0. 6 times 6 is 36, so 6 carry the 3. 6 times 4 is 24, add the 3 is 27. Now we're going to move over to the 1, but it's not really 1, it's 10. So I need to put a 0 in here to hold the place value. 1 times 0 is 0. 1 times 6 is 6, and 1 times 4 is 4, and we're then going to add that together. So 0, 6 add 0 is 6, 7 add 6 is 13, so 3 carry the 1, 2 add 4 add 1 is 7. So we've got 7,360 pennies, and we'll come back to that in a minute. For the lattice method, we take the number at the top and we multiply it by the number at the side. So 0 times 1, that's just 0. So we put in 0, 0 for that box. 0 times 6 is 0, 0. 6 times 1 is 6. So that goes there. We just put 0, 6. 6 times 6 is 36. So I put 3 on this side and 6 on this side. 4 times 1 is 4, so 0, 4. And 4 times 6 is 24, like that. And then we just add down each diagonal section. So I'm going to add down each of these diagonals, and that will give me my answer. So just 0 in this one. 0 add 0 add 6 is 6. 6 add 3 add 4, that's 13. So we put 3, carry the 1. 4 add 2 add 1, that's 7, and then there's just 0 in that top one, so we leave it like that. And we've got the exact same answer, 7,360. Now, as examiners, as teachers, we do not care which one of those methods that you use, as long as you are confident with one of them. So if you're a parent or if you're someone, you can just give your children or test each other, give them 3-digit times 2-digit, and just make sure they have a method and can get that right, and you can check it on a calculator if needs be. Now that's in pennies, isn't it? 7,360 pennies. Of course, the electricity company are not going to say, you owe us 7,360 pennies. We're going to want to get that in pounds, and to go from pennies to pounds, you're dividing by 100, so that is £73.60. There we go. For 4 marks, that's the correct answer. Question number 12A. Now I think it'd be daft to walk into the non-calculator exam and not expect to have fraction arithmetic. It's there almost every year. So when we're adding and subtracting fractions, we need to make the denominators the same. So for these fractions, I'm going to make them both out of 12. Reason I'm using 12 is because both 12 and 6, 12 is in both the 12 and the 6 times table. You could use 72, you could times them together. You could use 24. There's lots of different numbers you can use. I'm going to use 12 because it's the first number in both their times tables. So it's the lowest common multiple, and it's just going to be the easiest because I don't need to change this fraction at all. I haven't changed the bottom, so I don't need to change the top. With the second fraction, I've multiplied the denominator, the bottom number, by 2. If I've times the denominator by 2, I also need to times the numerator by 2, and 1 times 2 is 2. Now your denominators are the same, you can go ahead and add them together, so this would be 7 out of 12. And the method would be exactly the same if you're adding or if you're subtracting, make those denominators the same. So 7 out of 12. For part B, we're timesing. Now this is my absolute favourite question to be asked because you do not need to make the denominators the same. You do not need to make the denominators the same. We can just do the top times the top and the bottom times the bottom. So 3 times 5, that's 15. And 10 times 8, that is 80. So we're just timesing across. It's the nicest question you can be asked, but we have to simplify it. So we're looking for a number that we can divide them both by. What times table has 15 in it and also has 80 in it? And that's going to be 5. So we're going to divide the top by 5 and divide the bottom by 5. And that leaves us with 3 over 16. Dividing by 5 is easier if you think about it as dividing by 10 and then doubling it. So dividing by 10 is 8 and then doubling it is 16. So 3 over 16 is your final answer. We had to give that one in its simplest form, but with the one above, if you didn't, you still got full marks on that one. So there we go, that's 2 marks. Question number 13. There are 15 sweets in a jar. 4 of the sweets are red. Jill takes at random a sweet from the jar. Write down the probability that the sweet is red. Well, 4 sweets are red out of 15 sweets in the jar altogether. So our answer for that one is 4 out of 15. They're in the habit recently of asking what's the probability of not picking red, in which case it would be all the rest of them. So that would be 11 out of 15. Part B, there are only green counters and blue counters in a bag. A counter is taken at random from the bag. The probability that the counter is green is 0.3. Find the probability that the counter is blue. Well, we know that probability adds up to 1, and since there's only green and blue counters in the bag, the probability of it being blue must be the rest. So we're going to do 1 take away 0.3, the rest would equal 0.7. Question number 14. Y equals 6x minus 5. Work out the value of y when x is 4. So to get y, we need to do 6 lots of x, take away 5. So 6x means 6 times x. So whatever x is, we're going to multiply it by 6 and then take away 5. So if we're being told that x is 4, then we're going to change that x to be 4, and you're substituting. So the x comes out and the 4 goes in. So we're going to swap those over. 6 times 4 is 24. So we're going to do 6 times 4, 24, and then take away 5, and that is 19. Question number 15. Work out an estimate for the value of 92 times 1.63. You must show all your working. So when we estimate, we round to one significant figure. So, oh, that's not a 1. One significant figure. So we're going to round to one significant figure. That means 92 becomes 90. So I'm going to use the roughly equal to symbol to say this is sort of equal to, times, and then 1.63, 1 is the first significant figure, the 6 tells us to round up, so we're just going to call this 2. Some of you might be tempted to round it to 1.6, but that's not going to make it easy for us to do in our heads. So when you estimate, just round it to one significant figure. It doesn't have to be that accurate, it's just a rough estimate, okay? And then 90 times 2 is 180. So that would be our answer for that one. And then part B says, given that 2.96 times 3.2 is 9.472, find the value of 29.6 times 32. So there's a couple of ways you can do this. We can say, okay, well 2.96 has become 29.6, and that is 10 times bigger. And 3.2 has become 32. That is also 10 times bigger. Therefore, the answer must have been made 10 times bigger for the first bit and 10 times bigger for the second bit. So overall, our answer is going to be 100 times bigger, which would be 947.2. So that's one way of doing it. The other way of doing it is to estimate and say, just as we did for the question above, look at this question and say, okay, well, what is that roughly? And it is roughly 30 times 30. Now, 3 times 3 is 9, and then adding the 0, making it 10 times bigger twice, is 900. So we're saying this needs to be roughly equal to 900. And 947.2 therefore makes sense. That's a sensible answer. It's not going to be 94, that's nowhere near, so we're happy that that answer makes sense, and that would be the correct answer for that mark. Question number 16. Savio leaves his home at 7:30 to drive to work. He drives a distance of 50 miles. Savio thinks he drives at an average speed of 40 miles per hour. If Savio is correct, at what time will he arrive at work? So as soon as we see a question involving speed, involving distance, we want to draw our triangle, and remember that is speed, distance, time. And then within that triangle, we cover up the thing we want to know and we do the sum that's left behind. So if you want the time, you cover that up, and we're doing distance divided by speed. If you want the speed, you cover that up, and we're doing distance divided by time. If you want the distance, we'll cover that up, and you're doing speed multiplied by time because they're next to each other. So that formula triangle is really helpful to remember. Now, if he's leaving his home at 7:30, we want to know what time he's going to arrive to work. They're asking us to calculate the time. So we're going to cover that up and do the sum that's left behind, which is distance divided by speed. Distance is 50 divided by speed, which is 40 for this question. Now 50 divided by 40, I don't have a calculator for this. This is the non-calculator paper. 50 divided by 40 is the same as 5 divided by 4. And we know that that is 1 1/4 or 1.25. So in terms of time, that is in hours. We did the distance in miles, we did the speed in miles per hour, and therefore the time is in hours. Always your units will match up or should match up. If they don't, you need to do something about it to make them match up. So 1¼ hours it's going to take him to drive to work. Now, if he left at 7:30, we need to go 1¼ hour on from that. Now, 1 hour would take us up to 8:30. Quarter of an hour is 15 minutes. So that is going to be 8:45 a.m. 8:45 a.m. is the answer. And you make sure, please, that you put a.m. or p.m., whatever the answer was. But we need to specify what it is because otherwise they won't know. So 8:45 a.m. In fact, Savio's average speed was greater than 40 miles an hour. Okay, cool. So he was going quicker. How does this affect your answer to part A? Now, if he's going quicker, what's going to happen to the time he gets to work? Well, he's going to get there sooner, isn't he? And even if you can't answer this question in the exam, the top bit, you can always have a go at the part B. So don't be put off. Never leave a whole question blank, or never leave a question blank, to be honest. Always have a go. You're better to write something. The examiners don't know who you are. We're only going to mark it, and if it's blank, then we're going to give you nothing. So you might as well write something and have a go. You never know, you might be right. So if Savio's average speed was greater, then he's going to get there earlier. So if Savio is travelling quicker, he will get to work sooner. And it might seem really obvious, but that's exactly what they want you to say, okay, for 1 mark. Oh, I absolutely love these questions. Question number 17. 72 people did a test. So this is called a frequency tree. It's not probability, or sometimes the part B is about probability. Let's see. Yeah, normally always. This is a frequency tree, so we're just filling in how many people are at each section. So 72 people did a test. 20 of the 32 adults who did the test passed. So 20 of the 32 adults who did the test. So there were 32 adults that did the test, so that goes there. And it says 20 of them passed. So we're going to put 20 in that box there, or circle, whatever. Now, if 20 of the adults passed, we know that 12 of them must have failed because these two circles together need to add to make whatever number is here. So these two here need to add to make 32. Now, I also know that there must have been 40 children because 32 add 40 needs to add to make 72. So that one has to be 40 because that would be the rest. And then we know 6 of the children who did the test failed. So 6 would go in this one here. And how many have passed? Well, that would be the rest. 6 add something that makes 40, and that's going to be 34. So we've filled that out completely. That's for 3 marks, lovely. One of these people is picked at random. Now that's really important. We're picking from everyone. So that means the denominator, the bottom number of this probability, is going to be 72. If I was only picking from the girls, normally it's boy-girls, sorry. If I was only picking from the adults, it would be out of 32. If I was only picking from the children, it would be out of 40. But because we're picking from everyone, it's going to be out of 72. Find the probability that this person is an adult who failed the test. So that is going to be these people here. They are the adults that failed the test. So we're looking for those 12 people. So your probability is 12 out of 72. Now, some of you might think, well, that simplifies. That simplifies to be 1/6. And you are absolutely correct. It does. But they didn't ask us to simplify it. And with probability, we don't normally bother. So you're absolutely fine. If you did simplify it to 1/6, you would also get full marks. That's absolutely fine. Question number 18. Here is a list of ingredients for making 10 scones. So here are the ingredients for 10 scones. Mia wants to make 25 scones. Work out how much sugar she needs. So if our recipe is for 10 scones and Mia wants to make 25 scones, she needs to multiply this recipe by however many times bigger that is. And to find out how many times bigger it is, we're going to do 25 divided by 10. So 25 divided by 10, it's almost going to get you the scale factor. It's going to tell you how many times bigger it is, and that is 2.5. So in order for Mia to make 25 scones, she needs to multiply her recipe by 2.5. But actually, this is a really nice question because we only need to do sugar, and sugar, we can see, is 40 grams. So I'm going to take 40, and I'm going to times it by 2.5. Now, the easiest way to times by 2.5 is to say, right, one whole lot is 40, and another whole lot is 40, and half a lot is 20. So that is 2.5 lots of 40. We've got one whole, another whole, and half a lot of 40. And altogether, that is 100 grams of sugar. There we go. Question number 19, increase 240 by 20%. So to find 10% of a number, we are going to divide by 10. Imagine that this bar here is 240. If I want 10%, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I want to split that number into 10 equal sections. Let's ignore my very wobbly lines. And I just want one of those 10 sections. So 10%, we're going to divide by 10. 240 divided by 10 is 24. Remember, when you're dividing by 10, you're moving all the numbers one place to the right. So 24. That means that 20% is 48. And therefore, if we are increasing 240 by 20%, we need to add that 48 on to that number. So 240, add the extra 48 is 288. And that's for 3 marks. Question number 20. Now, really tricky one this, and I did it a couple of different ways when I filmed this the other day. The diagram shows 3 identical rectangles, A, B, and C. 5/8 of A is shaded, so this is equal to 5/8. 9/11 of C is shaded. Work out the fraction of B that is shaded. So you can add them together, and the overlap, the amount that goes over 1, that is going to be rectangle B. Because if you imagine putting them over the top of each other, if you imagine this one, oh, that's A, and then you imagine putting C over the top, it would fill up a whole rectangle, but then you'd have this bit as extra. So if you were to add them together, the amount that you go over 1, that would be the answer. But I think we agreed the other day when I did this with some students that the easier way is to say, well, if the bottom of rectangle A is 5/8, then the top is 3/8. And if the top of rectangle C is 9/11, then this bit is 2/11. And then we know that this bit would be 2/11 and this bit would be 3/8. So we decided to add them together and then take it away from one whole. So let's start by doing that. 3/8 add 2/11. Now we said earlier that if we're going to add fractions, we need to make the denominators the same. So we need the first number that's in the 8 times table and the 11 times table, and that is going to be 88. So I'm going to make both of these fractions out of 88. What have we done to the first fraction to make it out of 88? We've times by 11. So I also need to times the top by 11 to keep that fraction equivalent. And that is going to be 33. With the second fraction, I've multiplied the bottom number by 8. So I also need to multiply the top number by 8. And 2 times 8 is 16. So 33 add 16, that is going to be 49 out of 88. But remember that that is the white bits. So that's this bit and this bit, and we want the rest. So I want to do one whole, because the whole rectangle represents one whole, take away 49 out of 88. Now, how can I write one whole so that it's easy for me to take this fraction away? I'm going to write it as 88 over 88, because 88 over 88 is equal to one whole. If I take away 49 over 88, then I can just subtract that because my denominators are already the same. So 88 take away 49. Now remember, if there's more on the floor, you're going to borrow from next door. 18 take 9 is 9, 7 take 4 is 3. So the answer to this is 39 out of 88. That is the fraction of that rectangle that is shaded. Okay, question 21. Here are the ages in years of 15 people. Show this information in a stem and leaf diagram. Now, they are always going to intentionally leave you a nice big gap here. And the reason they do that is to allow you to do a draft one. Now, a stem and leaf has to go in order. So I would always do one not in order first, and then I'd put it in order in the nice, neat, real one that they've got down the bottom. So STEM is the same as the tens. So we've got 19, 20, we've got numbers in the teens, numbers in the 20s, numbers in the 30s, and numbers in the 40s. So I'm going to put 10, 20, 30, 40 down this side. And then I'm just going to go through in order. Now, the reason I'm going through in order is because I don't want to miss any. So 19 goes here. That goes in the tens section. 28 goes here. 29 goes here. 33 goes here. 27 goes here. And you can see that this isn't in order, but I'm going through all of the numbers to make sure that I don't miss any. 37, 25, 27, 37, 17, 45, 47, 25 and 26. Okay, so now I know that I've got all 15 in my stem and leaf diagram. So 15 people, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I've definitely got all of the data and I now just need to put them in order. So again, 10, 20, 30, 40 on that side. I'm going to put 7, then 9. It is much easier to order them when they're already in the right category. So now I've got 5, 5, 6, 7, 7, 7, 8, 9, 3, 7, 7, they're already in order, and then 5, 7, they're already in order. And then the key can be any number you like. It doesn't even need to be a number that's there, but you just need to explain to someone how we read a stem and leaf diagram. So I'm going to put 1 line 7 equals 17. You don't need to put units, you don't need to put whatever, but if you do put units, they need to be correct. All I will say is that, and then I put a cross through that, so I make really clear to the examiner that that is my answer. When I have marked these previously, the most common mistakes I see is people missing out a number. So please, if the only thing you do is count the leaves at the end and check you've got 15, that is the most important thing you can do. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Because the most common mistake is that you miss a number and you don't want to miss a number, okay? That is the most important thing. If you miss one number, you're going to lose a mark. If you miss 2 numbers, you get no marks for this. And the third mark is for the key. If they don't give you a box for the key, you need to draw one. You always, always, always need to have a key. Okay, question number 22. The centimetre grid shows the plan and the front elevation of a cylinder. So the plan is the view from above. That's what the plan means. And the front elevation is the view from the front. Work out the volume of the cylinder. So let's just give this a sketch. What do we know? Well, we know that a cylinder looks like this. Oh, that is terrible. Oh no, I've saved it. It's not too bad. The front elevation tells me that the view from the front is 5 squares tall. So I can say that this is 5 centimetres. I also know from above that this circle is 6 wide. So it's 6 centimetres all the way across. So I'm using the plans and the elevations to get that information. So 6 centimetres across and 5 centimetres up. Now we've got to work out the volume of the cylinder. And to get the volume of a cylinder, it is pi r squared, because that's the area of the circle. And then we multiply that by how tall it is. So pi r, that is terrible, pi r squared times by the height. Pi r squared times by the height. Now the radius of this circle is the distance from the middle to the edge, which is going to be 3. If we know it's 6 all the way across, then it's going to be 3 to get to the middle. So that is pi times 3 squared. And then to get the volume, we're going to times that by the height, how tall it is, so times by 5. And that is pi times 9 times 5, because 3 squared means 3 times 3. And pi times 9 times 5, we can't get the actual decimal value because we haven't got a calculator for this one. Pi is 3.14159 and so on, but it just says leave your answer in terms of pi. So that means we're just going to multiply the 9 and the 5 together, which we know is 45, and we're just going to leave the pi afterwards, just like we would with an x or a y if it was algebra. We'd just write it next to it and say we're timesing it by pi, but we're not going to actually do it because I don't have a calculator. So we just say our answer is 45 pi. Question number 23. Now when you are solving, this is an inequality, but same as when you have an equation, we're going to put a dotted line where the equals or where the inequality symbol is, and we're going to solve it. Now the aim of the game when we're solving is to get the x on its own. So the first thing I'm going to do is add 27 to both sides. The reason I'm adding 27 is because this is subtracting 27 and I want to get rid of it. So if I add 27 to both sides, 7x is less than 35. Now I've still not quite got that x on its own. It's 7 lots of x. So I need to get 1 lot of x, and to get that I'm going to divide this side by 7 and also divide this side by 7. So x is less than 5. And that would be my answer. Now be really careful, don't put 5 on the answer line. You have to put x needs to be less than 5. Because if you just put 5 on the answer line, the person reading it doesn't know if it equals 5, if it's bigger than 5. But for this inequality to be true, for 7 lots of x, take away 27, to be smaller than 8, x has to be less than 5. Okay, question 24, write 124 as the product of its prime factors. Another really, really common non-calculator question. So 124, and we're going to split that up. So I'm going to go for 62 and 2. And if you get to a prime number, you circle it. A prime number, remember, is a number that's only in its own times table and the 1 times table. 2, 3, 5, 7, 11, 13, 17, and so on. So you can only divide them by themselves and 1 to give a whole number answer. And you can do this in any way you like, but we're just thinking of 2 numbers that times together to give 62, and that's going to be 31 times 2. Now 31 actually is a prime number. There's nothing that goes into it that you can divide it by to give a whole number answer. So we're going to circle that, and that's going to be 2 times 2 times 31. Now you might choose to write that answer as 2 squared times 31, but because it didn't say give your answer in index form, either of those would have got you full marks. If it did say give your answer in index form, you'd need to write it in that bottom way there. The most common mistake I see on that one is people putting commas. Never, never ever do it. It's the product, it's the multiplication of its prime factors. So make sure you're timesing those numbers in the circles together. Okay, question number 25. A delivery company has a total of 160 cars and vans. The number of cars to the number of vans is in the ratio 3 to 7. Now, if you watch my videos a lot, you'll know that for ratio, I like to do little lines. There's 3 little lines for cars, and 4, 5, 6, 7 little lines for vans. And we've got 160 in total across all of those little lines. So cars on the left and vans on the right. Now we need to take 160 and divide it equally across all of those lines. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 160 divided by 10 means I've got 16 on each of these lines. And that's going to allow me to work out how many cars I've got and how many vans I've got. So for cars, there are 48. I don't actually think I need to work out the number of vans, but if you wanted to, it's 112. 16 times 7, so 112 vans. Wonderful. It then says each car and each van uses electricity or diesel or petrol. 1/8 of the cars use electricity. So we need to do 1/8 of 48. Now I've not done a single foundation paper where we haven't had to do a fraction of an amount at some point. And to do that, we divide by the bottom and then times that answer by the top. But of course, if it's just a 1 on the top, it just stays the same. 48 divided by 8 is 6. So 6 cars are electric. 25% of the cars use diesel. So 25% of 48, and that's half and half again. So that's 12 cars. And then the rest of the cars use petrol. So all we need to do now is take 48 cars, take away 6, take away 12, and that gives us 30 cars. And that would be our answer. I think that was 5 marks, that one, if I remember correctly. Yes, 30 is the answer for that one. Really nice question, really common for 5 marks at around that point in the paper. Okay, question 26, and we've got standard form. I've got a whole nother video on standard form on my YouTube. If this is a question or if this is a topic that you struggle with, go and have a go at that. It's got a booklet in the description that goes along with it as well. Write 1.63 times 10 to the minus 3 as an ordinary number. So when we have 10 to the minus 3, that means we're going to divide by 10, divide by 10, divide by 10. A negative power means we're dividing by 10. We're making the number smaller by 10 that many times. So 1.63, if we divide it by 10, we get 0.163. If we divide it by 10 again and divide it by 10 again, we're going to get 0.0016. 3, that's the answer for that one. Part B, write 438,000 in standard form. So writing a number in standard form, we need this bit here where it is a number between 1 and 10, can't equal 10, but between 1 and 10, it can equal 1, times 10 to the power of something. So it's going to be 4.38 times 10 to the power of something. Now I can see that this has been times by 10. I want the decimal point to be here, and the decimal point is currently here. Now, obviously, it's not the decimal point moving, it's the numbers, but it's far easier to move a decimal point, so that's why I'm going to say that. 1, 2, 3, 4, 5 jumps, so that is 4.38 times 10 to the power of 5. Part C, work out 4 times 10 to the power of 3 times 6 times 10 to the power of minus 5. Now, we can change the order of this, and we can do 4 times 6 first. 4 times 6 is 24. And then when we times with indices, we add the powers. So this is times 10 to the power of 3 add minus 5. And 3 add minus 5 is the same as 3 take away 5, and that is minus 2. So this is 24 times 10 to the power of minus 2. Now it says, give your answer in standard form, and that is not in standard form because 24 is not between 1 and 10. So I need to make it between 1 and 10. 2.4 times 10 to the power of. Now, if you've made this bit 10 times smaller, then you need to make this bit 10 times bigger to keep the number the same overall. And 1 bigger than minus 2 is minus 1. So this is 2.4 times 10 to the power of minus 1. Okay, question number 27. Here is a regular hexagon and a regular pentagon. Work out the size of the angle marked X. Now, the formula for how many degrees are inside a shape is the number of sides take away 2 times by 180. But you might find it helpful to just remember that a triangle adds up to 180, a quadrilateral adds up to 360, a pentagon, a 5-sided shape, adds up to 540, and every time you add a side, you add another 180 degrees. So a pentagon is 540, a hexagon is 720. So therefore, I know that this one adds up to 540 and this one adds up to 720. If I want one of those angles, because it's regular, I can just divide the total by how many angles there are. So for this one, we're going to do 540 divided by 5. 5 into 5 goes once. 5 into 4 doesn't go. Let's carry all 4 over. And 5 into 40 goes 8 times. So this angle here is 108. On this side, if we want this angle, we need to do 720 divided by 6. How many 6s go into 7? Well, that fits in one whole time, remainder 1. How many 6s go into 12? That fits twice. How many 6s go into 0? That fits 0 times. So that is 120. Now we know that angles around a point add up to 360. 120 add 108 is 228. And then I'm going to do 360 minus that answer. If there's more on the floor, borrow from next door. 10 take 8 is 2. 5 take 2 is 3. And 3 take 2 is 1. That is 132. There we go. 3 marks for that one. Question number 28. Complete the table of values for y equals x squared minus 3x add 1. So with this, instead of trying to cram it all you're working somewhere, I like to lay it out in stages. So if you want to know what y is, you need to do x squared. You also need to do minus 3x. And then you also need to add 1. Those are the 3 things that you need to combine together to get y. So I'm just going to lay that out underneath and then I'll collect them all up and put that as my answer for y. So there we go. Let's do minus 1 squared. Now a negative times a negative, because when you square minus 1, you're timesing it by itself. A negative times a negative is a positive. So that is positive 1. And then minus 3 times minus 1 is 3. And then I'm just going to add 1. So altogether, 1 add 3 add 1, that is 5. For the next one, I need to do 2 squared, which is 4. I need to do minus 3 times 2, which is minus 6. And then I need to add 1. 4, take away 6 is minus 2, add 1 is minus 1. For the next one, I need to do 3 squared, which is 9. Minus 3 lots of 3, which is minus 9. And then add 1, which is just 1. And then I need to do 4 squared, which is 16, minus 3 lots of 4, which is minus 12, and then again we need to just add 1. 16 take away 12 is 4, add 1 is 5, and I now have the coordinates that I need in order to plot this quadratic. So we're going to now head down to the graph and plot each of them. So minus 1, 5 goes here, 0, 1 goes here, 1, minus 1 goes here, 2, minus 1 goes here, 3, 1 goes here, and 4, 5 goes there. That's going to get you 1 mark for plotting your points, and then again we just need to join those up with a smooth curve. I will do my best on the iPad here to connect those. We don't want to see a flat bottom. Remember, it needs to be a natural curve, so it does need to just dip slightly below and connect all the points like that, and that is the shape of my quadratic. So 2 marks for your table and 2 marks for drawing it. And it then says, using your graph, find estimates for the solutions of the equation x squared minus 3x add 1 equals 0. Now this is what we've just drawn. So they're basically saying to you, when does your graph equal 0? And equaling 0 is finding the roots. So we're trying to say, when does it equal 0? When does it equal this line here? That is the line y equals 0. When does your quadratic equal that line? And to find out, we're just going to look at the 2 places where it crosses the x-axis. And that's going to be 0.4 and 2.6. Now you might have got a slightly different answer to me, because obviously everyone's graph is going to be slightly different maybe, but that is the answers to those. Okay, question number 29. Here are 2 cubes, A and B. Cube A has a mass of 81 grams and cube B has a mass of 128 grams. Now, as soon as we're talking about mass, again, we're going to need another one of those triangles: density, mass, volume. The density of cube A to the density of cube B, we've got to work it out as a ratio and give your answer in the form A to B. Now, to be able to work out the density, if I'm covering up density, I'm doing mass divided by volume. I've got the mass, that's given to me in the question, but I don't have the volume. The volume is what we're going to need to work out. Now, the volume of a cube is length times width times height. So that's 3 times 3 times 3 for that cube, and 4 times 4 times 4 for that cube. So A has a volume of 3 times 3 times 3. 3 times 3 is 9, times that by 3 is 27 centimetres cubed. And B has a volume of 4 times 4 times 4, which is 64 centimetres cubed. And our mass for A is 81, and our mass for B is 128. Now we said to get the density, we're going to do mass divided by volume. So I'm going to do the mass for A, 81 divided by the volume of 27, 81 divided by 27. Now, if that doesn't come to you naturally, if you're not sure what the answer to that is, remember you can always simplify the fraction. So they're both in the 9 times table. So if we're dividing the top by 9 and the bottom by 9, we get 9 over 3. And you might find that easier. So we then know that that's 3. So the density of cube A is 3 grams per centimetres cubed. We're now going to do the same thing for B. We're going to do the mass, which is 128, divided by the volume, which is 64, and that is 2. So A has a density of 3 grams per centimetre cubed, and B has a density of 2 grams per centimetre cubed. They want it as a ratio, so we're going to put A to B, that's what they've asked for. And they've got to be whole numbers, they've got to be that, so there we go, 3 to 2, that's our answer for 3 marks. Question number 30, and the last one on the paper, write down the value of sine 30. Now, I remember triangles for this. So I remember this triangle here. This is 60 degrees, this is 30 degrees, this is 90, and then we go 1, 2, root 3. And if you want to know sine 30, well, we know that sine 30 uses the SO of SO katoa. And if we want to know what sine 30 is, we are going to do the opposite divided by the hypotenuse. Imagine you're stood here, your opposite is 1, your hypotenuse is 2, it is 1 over 2. Now they are very difficult to remember for the foundation paper, so if in doubt, guess a half, guess root 3 over 2, but definitely make sure you write something. But yeah, really tricky. Look at exact values to find out a little bit more about that. I hope you found that helpful. That's the end of the foundation paper, so I'm going to stop recording here. Let me know in the comments if you've got any questions.